Hey there, and welcome. For this demo, I'm going to walk you through a multi-cloud, multi-zone setup of Kong Mesh. Before we dive in, let's take a quick look at the architecture. Here, we have a single service mesh, joined across 3 separate cloud deployments, otherwise known as a multi-zone deployment. 2 are in GCP, East and West, and 1 is in AWS East. Each cluster is fronted with a Kong API gateway, where traffic is routed to our front-end application, which then connects to Redis to retrieve a counter. All of the services across every region are deployed in a service mesh, so each pod in each cluster has a sidecar proxy that talks to the rest of the services in the mesh. It's through these sidecar proxies where a mutual TLS is enforced and load balancing takes place. During the demo, we will showcase how Kong Mesh provides seamless application connectivity across availability zones, regions, and clouds, all while providing critical functionality to maintain the health of our applications. We'll start by showing the counter app and how requests to Redis are automatically load balanced across the 3 available backends. We will then dynamically change the load balancing policy to enable locality awareness, which tells the mesh to prioritize communication to services that are nearest geographically. We'll then simulate a failure to show how the mesh automatically reroutes traffic to other regions to maintain uptime and availability, all without manual intervention. And with that, let's get to it. Here is our counter application. Here is the counter that is being retrieved from Redis, as well as the zone in which it was fetched from. You'll notice that if I refresh the page here a few times, that the return zone varies. This is because we don't currently have locality-aware load balancing enabled within the mesh. So even though I've loaded the counter app from the East ingress, it may be fetching results from Amazon, from GKE East, GKE West. This is introducing extra latency in our application and reducing overall service performance. To fix this, we'll want to enable the locality-aware load balancing policy within the mesh. Here is the Kong Mesh control plane, which provides a high-level overview of the zones, services, proxies, and policies that are being enforced within the service mesh. From here, I can see the 3 zones that we have deployed, one in Amazon US East, one in GCP East, and another in GCP West. I can also see the services that we have deployed, including our counter application and Redis. Each have 3 data plane proxies, signifying that 1 proxy is available in each region. And I can even drill down into those proxies here from the UI and see metadata associated with each one. In order to enable locality-aware load balancing, we'll need to update the mesh custom resource definition that lives within the control plane. To do that, I will need a terminal. We can see what the current mesh definition looks like by issuing a get mesh command. Here you can see we have an empty routing component. In order to enable locality awareness, we'll need to issue a patch to add an extra value here. To do this, I'm going to issue a kubectl patch command. I'm going to add a locality-aware load balancing, and it's going to be set to true. Before I do this, I'm going to enable the auto increment feature inside of the counter app. With auto increment enabled, the counter will be automatically incremented, and we can see that the zone is currently swapping between East, West, and AWS. Now, if I issue this patch command, the counter is now pinned to the GKE East zone. I can then even look at my West ingress and validate that the same is taking place for the West ingress, where West is pinned to West and East is now pinned to East. I can go back to our control plane, view our default mesh, and you'll note now that locality-aware load balancing is now set to enabled. If I go back to the counter application and increment, you'll note that now we've stabilized on the East zone Redis. So East ingress now goes to the GKE East, and I'll click this a few more times, and you'll see this holds. Now if I load the West ingress and do the same, you'll note that the zone for the GKE West is now pinned to GKE West Redis. Now let's simulate a failure to see what happens with our routing. To do this, I'll pull up another terminal here. I'll need to switch clusters to my West cluster here. And then from here, I'm actually going to scale down my Redis deployment, where I'm using kubectl again, scale deployment Redis in my main application namespace to 0 replicas, effectively shutting off Redis in the West GKE environment. You'll note that it's still working. And if I scale this down, so I've scaled it down, hit increment here again, Note that now the mesh has automatically routed the requests around the west instance and is now back to the previous load balancing behavior between GKE East and Amazon US East. All of this without having to change any configuration or modify anything manually. In this demonstration, we showcased how Kong Mesh provides robust and resilient connectivity to services and applications deployed across multiple clouds and regions.